What's up, YouTube? How you guys doing? I'm doing great. Thanks for asking. And it's 2023, but I'm doing 2009 SolidWorks Mania. Beat this part right here. Let's get into it. File new. Let's go to regular part. Default settings like always. Phase 1 drawing. Material aluminum. Nice that they're giving us some materials this time. Does this give us the units? Ah, man, looks like they're forgetting the units. Why? Ah, wait, I see 2 millimeters here. I'll go with millimeters. Let me see, 8 degrees, but that's a reference dimension. All drafts 4 degrees. Oh, so they're starting off the drafts right away. And then all this has draft. And it's one thickness at the very top. I might start on the right plane because it has the most definition. I start here on the top. I got 1 boss extrude, 2 boss extrude. I can extrude up, extrude cut. Get all the radiuses. What's this right here? Oh, there's a hole in the back. I didn't realize there's a hole. Okay, I think I know where to start now. So I'm going to go with the top first. I can get this 125. Do both these centers. And it gives me diameters. So yeah, definitely top first. And I'm going to reverse this. I'm going to do the small hole and the right. I'm going to throw that on the right side. This bigger hole on the right side. 60, 15, 45, 25. So the goal here, actually, let me get this. Let me do the through cuts as well. 125. I don't like that. Keep it like that. There we go. See, 45 through, 15 through. 15, 45. Let's draw a center line across both of them. Cool. What is the full height? So we're going to do this in 2 boss extrudes for the sketch. So first boss extrude for the small one, and then the second one will have its own boss extrude. And it's the same sketch too. So this one, I'm going to do the selected contours. I'm just do this one first. And this tiny one's 60. And should I do the draft already? Should I not? I could do the draft. Actually, I could probably do the draft with all of this all at once. 4 degrees, that's 8 degrees reference. 20, now let's do it. At 4 degrees. Actually, there's something interesting about this. That through hole doesn't have draft. So what we're going to need to do is that the selected contours has to include the center as well. Oh, that's interesting. So let's go back. I'm going to change both these centers to constructions. Now let's go here, 20. Selected contours, just this one. And I'm going to draft it 4 degrees. Then we review, go back to the sketch, extrude boss. Let's check out the dimension. 40, offset 30. So offset here, 30. Change the selected contour just to that sketch. There we go. This one's going to be 40 with a draft of 4. Nice. Actually, let me go back on what I just said. I'm going to actually remove the draft and do it later on. So let's remove the draft. And this time I'm going to go back to the sketch. Make this not a construction anymore. Go back to this sketch. Oops. Let me go back to the sketch first. Make this one for construction. and then remove that draft. I'm going to do the draft all at once. Well, not all at once. Hopefully I could do it all together. And then this one's going to be SolidWorks. We'll make a new folder. That is not the name. Model Mania 2009. Nice. Let me go to the right plane. Oh. Let me change one thing here. I made it to the right. I actually wanted to go up. So I'm going to remove the horizontal. And I'm going to change that to a vertical. There you go. That way I have it like that, and it gives me a good view. Now I'm going to go to the right plane. And I'm going to check out this sketch right here. 40, 50 from the centers. Go right to the midpoint here. Horizontal. Does it give me degrees? Nope. Because the radius is giving me 40 and 50 though. 50 here. 40 here. And 20s. I'm going to add that later on though. Actually, 20s. They're asking for this to be done in all one sketch. Extrude boss. Mid plane. What is the thickness of this? Thickness is 6 millimeters. What I'm going to do, let me flip that first. Save that. What I'm actually going to do is I'm going to scroll this up real quick. I'm going to draw a sketch here. And this what helps with is I'm going to do a center line. And it helps with, if I do that boss extrude, I could go to the vertex instead. So instead of like some dimension or duplicating dimension, I go up to vertex, and that holds my diameter. So if I change this diameter, this entire thing changes. Oops, not up to surface, up to vertex. Boom. Now I'll go to the top view. I'm going to do a line like that. Make this tangent to this. Make a tangent to the other one. Make a center line. Now make this touch. I'll cut that all off. Actually, I'm not going to make a touch. I'm going to make it go all the way through. And I'm going to do that right there. Pull this all the way through. Tangent. Oops. Now, I don't know if you guys noticed, but I'm going faster and faster because I know you guys catch up with me. As we keep on going through these, I'm going to keep on going faster and faster. See if you guys keep up. That'll be good to build up your skills, and also makes it a shorter video so you guys have to wait the entire thing, just me explaining every little thing now that you guys probably gone through a couple of them. And if you guys haven't, check out the other ones. You see both. There's no end condition. There we go, which is something I don't want. So I'm going to use delete patch to take that little detail out. There we go. And this one actually didn't do it the way I wanted. Oh no, it just wasn't long enough. So we can fix that with another delete and patch. Crazy, insane, powerful tool. And then the extrude cut. I'm also going to include this surface as well. Cool. Save it. Okay, now we can do the center rib. And The way we could do that is we go right plane here. And what I'm going to do here is I'm going to do the intersection curve of the inside of the holes. If I do the outside, you're not going to get a good rib. Right here will give you a good rib. Right click, select tangency, convert entities. And let me check out this rib. 2025. Okay, so I'm going to do, I might have to take out these, but I can do that later on. So I'm going to offset these by that 25 measurement. Actually, I made a mistake. It's not 25. Only this side's 25. The rest could stay the same. So what I'm going to do is convert entities both of these as well. I'm going to start trimming stuff just to clean it up a bit. There we go. Move this line. Move this line. This line down here is going to get to 25. No chain select, only that line. Press OK. Smooth that over here. That up there. Trim, power trim all that off. And then add those 20s. 20s, 20. Yes, yes. And it's going to be a 6mm rib. Probably missed the line, but that's fine. I could do the region. There you go. And just merge it all. There we go. Beautiful looking part. Now all that I'm missing is all of the drafts. 8 degrees 6, got all these dimensions. I'm just making sure I caught all of them. The hole. I'll save that hole to the end. And however, I do need an extra sketch. So if I go back to my sketch I did right here, I'm actually going to make one of these go back as well. And that's going to create a plane. That's going to create, yeah, I do. Make this visible and create a reference plane here right on the dot. And that later on is going to be that thread. Or I can even make it right now. So I go Hole Wizard. See what kind is it? Is a M10 by 125 thread through, I'm assuming not through all, only through up to the surface. So let's go to that tab tool, M10 125 positions, right down the center. Let's take the center line, make sure it's centered, and then the position from the center, from the bottom is going to be 20. So right there, 20. Press OK right here, and the type is going to go up to next. There we go. Press OK, and I got my hole there. Nice. Save that real quick. Hide that. And now we can do the drafts. So let me think. The draft. How am I going to do this draft? We're going to use the draft tool, but we're going to use the parting line version of it. So we're going to go to draft. We're going to go to 4 degrees. We're going to go to manual and then the parting line. We're going to right click this outer line, which is going to be the parting line of it. Select the tangency. It's going to select all these edges that are tangent to each other. And we're going to do by 4 degrees. And our direction of pull is going to be this vertical line. So let's press OK. And I did something wrong. Let me deselect all these. Right click and select tangency over again. My direction of pull is going to be this vertical line here. There we go. 4 degrees. Press OK. There we go. Now I got that 4 degrees all the way around. Now let's try it again. And we're going to do it this side. So we're going to go to draft. We're going to right click here, select tangency. And we're going to do it on both sides of this face. Right click, select tangency. And the edge, the direction of pull. I gotta find, I actually don't have a vertical line this time. I wonder if I could choose, nope. There you go. I could choose that center of the circle as my direction of pull. Yeah, let's press OK. And it's in the opposite direction of what I want. So let's reverse it. This direction. There we go. Let's save that. And let's do the draft analysis. Evaluate, draft analysis. And I'm going to set this down to 1 so you guys can see the clear difference. You see 4 degrees all here. 4 degrees, 4 degrees. This wall is 4 degrees. Nice. I gotta admit, that parting line draft, super cool. Okay, there's gotta be some radius in this, right? The R2 radiuses. And cool. I know where they're at. So let's try that. 2 radiuses. Grab the top here, grab the crown here. This wall. This wall. Let's complete that. That edge there. That'll grab all of that. And this outer edge. There we go. Forgot this one right here. Press OK. Yep. 8 of them. Let's change the colors. Actually, first let's add the material. We're going to head down to, not steel, we're going to go to aluminum alloys. It's the 6061, right? 6061 alloy, aluminum, and specific T4 series, T6 series. Apply. Close that. I'm going to change this aluminum color to that yellow color. It's a natural kind of aluminum color. Or it could be, you know, powder coated or some sort of coating on there instead, if you guys want to imagine that. Right click the radiuses and let's turn these red. There we go. Now it looks all good through to bore. Nice. Exactly what we wanted. Press save. Okay. So what we're going to do is we're going to rename this to phase 1. Not like that. Phase 1. Get phase 2. And let's go check how that one is. Restrain this phase, apply it 1,000 Newton force, use Simulation Express or SolidWorks Simulation to analyze and determine the factor of safety and maximum deflection of the part. Record the factor of safety and maximum deflection for the part. So SolidWorks Maker actually doesn't include any of the simulation packages, just purely modeling. So I'm actually going to hop onto my professional computer and actually do the simulations there. But for those of you that can't access any simulation software, we're just going to have phase 1. I'm going to save that, and you guys could copy these settings right here or compare it against yours and see how you guys did. Remember that this model is going to be available for you guys to check out. You guys can mess with it. It's going to be you're going to be able to open it in SolidWorks Maker 2023. If you guys don't have the install for that, I have a link up. I have a install video on that. Links in the description. You guys could check that out. And then be using the same software I am, and you guys could follow right along. Cool. Thank you guys for watching. Like, comment, subscribe, and hit me up if you have any questions. Peace. I had to put in an extra part because SolidWorks Maker, from what I know, doesn't have simulations. So I had to bring it into, you know, another version of SolidWorks in order to simulate it. So right here, I'm going to show you guys how to simulate it. This is not SolidWorks Maker. But at least it's still SolidWorks, and you guys get an idea of how to do it on your own. So let's get into this part. So, oh wait, here's the first part of it. The second part, if we look at it, they're asking us to restrain this side, apply 1,000 newtons load to this face in this direction, and we're going to use Simulation Express or SolidWorks simulation to analyze and determine the factor of safety and the maximum deflection of the part. Record the factor of safety and maximum deflection for the part. So let's go ahead and go to the Simulation Express, which will be right here. Simulation Express, Analyze Wizard. Before I go too far into this, I'm going to add the material. Let me see what the material was, because this is now a step file put into this. So it's a 6061 T6SS. So it's aluminum. Let me drop down this menu. Aluminum 6061 T6. There you go. I'm going to apply that. Close it. Welcome to Simulation Express. I'm going to press next. I might hide my face in order you guys can see it. There you go. Add a picture. So our picture is going to be this hole here on both sides. It's only like that for me because I imported it. So I'm going to press OK here. I'm going to go to next. I'm going to add a force. Now the force has a direction, if I'm looking at this correctly, on the part 2. The force in direction downwards, but it's going to be in the hole. SI of 1,000 newtons. It's going to be in this hole on both sides. I'm going to select my direction, which my direction will be basically perpendicular to my plane. Do I need a total force? Do I need a particular plane? There we go. Reverse the direction, 1,000 newtons. And press OK here. Adding existing. Okay, so there's my direction and my force. Go to next. The young modulus and all that. Next. Run simulation. Gonna create the deflection. Does your part deform as expected? Yes. And continue. And then our factor of safety is 3.15. And let's see the amount deflected. Displacement show. Let me zoom out here. The maximum displacement is going to be at this area, which can be 3.18 in millimeters. So it's going to be 0.0318. So not much. And that's pretty good, actually. That's actually a relatively strong part. Okay, well, that is how you find the displacement and apply a force through Simulation Express in order to get the factor of safety.